Squeak. 12 plus 3, 3 plus 2.
Yeah, and I think we have 15 minutes more than this session. So
should be okay.
Brilliant. I'm going to go and shout to tell people to get.
Go for it.
When are you squeaking then?
It's 12 plus 3
Yeah.
for you, and then 3 plus 2 for the line. But I'll probably do the. I guess the usual system is just the stand up for 1 minute and then squeak for.
Shut up.
Now it's done. Because I don't want to squeak while someone's in the middle of presentation, unless it's their fault.
I went to a macro ES conference. I had to Loch Ness Monster and maybe the haggis. And they did the haggis and you could just taste the lips. And the Loch Ness Monster chasing the haggis. And you had like when you're running out of time. So
Yeah, but they had. Is this something I guess is like normal thing?
I think it's Edinburgh. I saw that, and me and Tom I think Tom gave me one. I've got a white one on my desk. I thought it was like a guinea pig or like a bat or something. And we got those in.
Jane, are you going to read the title?
Yeah, probably. Well, probably just probably summarize or read the title. Yeah. What to say? It's good talks about biases in iNaturalist's model.
Yeah.
There you go. Would you rather I read the whole title or?
Okay.
I got it sweet. Read the whole title backwards.
Yeah, systematicians and developers intelligence artificial between moi.
It was going so well.
I didn't expect it to go that well.
Okay. Easy though.
All right, we're actually already 1 minute into the session. Going well.
Here they go.
No.
Welcome. Okay, now that I've seen our first speaker has entered the room, we can start the morning's alternative session. Thank you all for coming. It's going to be focused on capacity ethics, and then we're going to have some lightning talks in the end. It's going to be 12 minutes plus 3 minutes of questions is the idea for the long talks, and then it's going to be 3 plus 2 for the flash talks. So this is going to be, I'm going to try and stand up for a 1 minute warning, and then I'll squeak when it's like. Great, and first up we have Noé Barbier, who has actually attended the Access 2025. So if any of you are interested in the summer school that we run, I want to know if it's good, then get up to him. And he's going to talk to us about biases in iNaturalist's model using bGenera.
Yeah.
So yeah, take it away.
Okay, so hello everyone. I'm Noé Barbier. I'm a third year PhD student at Sorbonne University. And so today I will present to you biases in iNaturalist model that we exposed using a highly diverse genus, so Andrena. And we are calling for more bridges between artificial intelligence developers and systematicians. So as you know, it's a critical context for pollinators in terms of abundance and diversity. And we have, there is a need to have species level identification because conservation measures and monitoring are based on species level identification. And so it means that we need large data sets with reliable identification. But we have some issues because there is a lack of experts and tools able to do such a data set. And so there are two ways to get large data sets. Insect detection is one, but you have also citizen science. The problem are its reliability of the identifications. And so in this study, we are focusing on one of the most popular platforms worldwide, iNaturalist. And iNaturalist to avoid this type of problem is proposing an AI assistance with identification. And so the annotation at genus level is commonly too broad for this type of hyperdiverse taxa because you have huge diversity in terms of ecology and stuff, but it's not always possible to get at the species level. And so we are trying to get a more reliable way to annotate images for such group. And we decided to create a new taxonomic layer between species and genus level that are adapted to image data of such groups. So the focus was on female of the most diverse genus of well-being in France, so Andrena, that represents 181 species. We focused only on female because there is a huge differences in terms of morphology between males and females. And so, yeah, this group have a huge diversity in terms of morphology, lexism, but you have also very cryptic species as these four species. And so the first step was to build morpho groups for photo identification of the genus, and then trying to re-annotate iNaturalist datasets thanks to this new taxonomic layer. And so these new morpho groups were based on multiple ID keys, photographs, websites, and collections. And we try to maximize the taxonomic resolution by getting as close as possible to species level. We try to use accessible visual criteria to have the criteria visible on photos. We try to limit the intraspecific variability by using stable criteria among the groups. To minimize the permeability by getting species in only one group and to don't have the same species in different groups. And to maximize the internal homogeneity, so to have among groups morphological consistency. And so these are the 64 morpho groups we built. You have 38 monospecific groups when identification is possible based on images. So here are a few examples. We had 16 groups with less than 5 species as the Lagata group, where you have really cryptic species, but yeah, that's it. And 10 groups with more than 5 species, such as the platypus group. So then we try to assess the relevance of AA-based suggestions on iNaturalist. And to do so, we scrapped a dataset and we annotated more than 10,000 photos at the morpho group level. Then we reduced the observation in the dataset to only observations that correspond geographically and temporally to several species in morpho groups. So observation when confusion was possible between species of the same groups. And for the many species that weren't included in the iNaturalist model, in our analysis, we substitute the species by the subgenus to test the indirect representation of the species in the suggestion model. And so from this, we extracted the top 4 suggestions of iNaturalist. And we compiled them based on morpho groups. We calculated a metric and statistical test. So the metric is the global coverage. It's the percentage of relevant suggestion by morpho groups. And then we did the chi-squared goodness of fit test, where we compared observed and theoretical expected frequencies of relevant suggestions. So the theoretical expected frequencies are of 1 on n, when n is the expected number of relevant taxa suggested. And when it was significant, we analyzed the standardized residuals to know which species was over or underrepresented in the suggestion. So we calculated the global coverage for 8 morpho groups. You can see that we have low coverage rates with less than 50% of relevant suggestion for 6 of our 8 morphogroups. It can be explained because of the non-exhaustivity of the model, but also of the platform. When we did this analysis, 2 species were missing in iNaturalist for France. Another problem is that data do not need research grade to be included in the training, and so you can have poorly or most misidentified photos in the training datasets. And it can be also explained because subgenera are almost never suggested, and so the humanist group is the only exception with a really good rate. And for this group, every species belongs to the subgenus Andrena, and the subgenus was suggested commonly, and so you have a relevant suggestion for this group. The frequency test shows that suggestions are biased towards common species, but today I will present you in detail only for the result for the Flavipes group in this talk. And so the Flavipes group is composed of 6 species, with only 3 that are included in this model. And amongst the 25% of relevant suggestion, you have an overrepresentation of Andrena flavipes, an underrepresentation of Andrena gravida, and a representation close to expected for Andrena viabilis. And so Andrena flavipes and Andrena gravida are 2 very common species that are distinguished by view, thanks to the color of the hair, that are more whitish in gravida and more brownish in flavipes. But this criteria is only visible on fresh specimen, and color variation exists, so it's not very stable. And so, yeah, the differences that seems a bit surprising between the suggestion of the species can be explained because of the models that are giving you a list of suggestions, even when it's not confident. This problem is known to be exacerbated for groups that need close observation, and so it's the case for this genus. Then this list of suggestions leads to bad user practices that tend to give an identification even when they almost don't know the group or the other possible close species or possible confusion. And then other users are confirming, following exactly the same process, and that leads to something that is known as well. The research grade is not always reliable on iNaturalist. And I spoke with a lot of experts that told me that for common species, after that, they do not make the effort to verify the identification. And so for such group, you can have really sometimes poor data. And so the consequences of all this are felt by beginners that end up with a simplistic view of real diversity, but also in research with many studies that are carried out on data not always reliable. We need to encourage broader level identification in models and just let experts refine it after that. For example, in this study, the Andrena genus is often correctly identified by the model, but genus level is sometimes too broad, and so it's possible to go further based on photos by doing intermediate morphogroups, as those we defined in this study. We can also add guides and tutorial in iNaturalist to inform users on which criteria are relevant to take in photographs for each groups. And iNaturalist could be more transparent about model shortcoming and establish stricter validity thresholds for observation used for training. And another area of improvement is getting a warning in case of phenological overlap. So when confusion between 2 species of the same morphogroups is possible, just get a warning on the app. And so currently we are trying to assess the relevance of this annotation to model performance and the ability to use more photos. And so to test this, we are trying to answer two questions. So the first one is, can it help to increase the reliability of identification, so using these morphogroups? And the second one is, there are significant benefits to using more photos thanks to these approaches. So we are training 4 datasets, one at species level, that is raw, to test the benefits of cleaning datasets. And we will compare it with clean species level datasets, where I removed poorly cropped and misidentified images. and where we are focusing only on females, so I removed males as well. We will also test morphogroup level datasets, so it's the same as the two first one, but annotated at the morphogroup level. And finally, we will test and train an unenriched morphogroup level datasets thanks to the re-annotated photos. So, for example, photos that were previously annotated at the genus level, and now that we can include it by annotating at the morphogroup level. And so thank you for your attention, and I'm looking for postdoc for next year. So if you have any ideas.
Thank you, Noi, for a really well timed and awesome talk. It's really brave you're tackling this taxonomic issues with image-based ID. Any questions for Noi? Let's start at the back.
Thanks. This is really nice work, and it very much observations on iNat. Are you in contact with iNaturalist's, and are you asking them to do some of these issues?
I was in contact with iNaturalist's because I wanted the list of species included in the model. So I contacted them to do so. But this work is not published or stuff. I'm currently working on it. And so I think after the study, I will do feedback to iNaturalist's and
maybe they would like to hear before you publish.
Okay. Yeah. Okay. But yeah, I'm in contact with them. But this work on iNaturalist's starts and like 1 year before. It's a good idea.
And I quickly add something. Maybe you could become the curator of iNaturalist's for this family project, which is not a lot of work, and they need those.
Yeah, the internship students that worked with me used to propose new morphogroups and new groups, because for Andrena in France, you have only one group for now. It's the Agelisma group, but it can be, a confusion is possible with Agelisma species because it's not really clear between group and species. So, but yeah, we want to include more groups like this.
I was curious if you did any investigation in the sense that you have features of the image, like so the amount of details you can get out of an image, the camera center, and so on, and the taxonomic resolution, like the lowest taxonomic level you can arrive to work, that would impact the way you group these species or genera as well. Have you thought about this, and have you done work in that direction?
You saying by getting like knowing which parts heat map maybe or stuff?
For example, if you, sometimes the camera sensor stores information about focal distance, stuff like this, you know, so you have some features in the image that would dictate your capacity to identify that insect to whatever taxonomic level. That makes sense.
Yeah, for real. But no, I didn't do this because I'm new in AI stuff. I'm more a systematician for now, and I don't have a lot of people who work on this kind of question. But I'm getting bridges with my single shop, which is working on AI in France. And so yeah, maybe I will try to go on this with him.
Any more questions? I was wondering, with your morpho groups, did you find that they were readily identifiable based on almost any picture, or is it usually you need the specific orientation of the individual? Yeah.
It depends. Like as we suggested at the end of the talk, you can do guides and tutorial to tell people to get I don't know, cis criteria and stuff. But we based morpho groups on visible criteria and stable criteria. So we wanted most of the time to be able to annotate photos, and we lost. We weren't able to annotate really a few photos, and we had more. The data set at the end was even larger than the one we built, because you add the genus level images that you are able to annotate. So you don't lose so many species or stuff. Most of the time you can classify in groups.
And I also wondered if you played with confidence scores at all.
Sorry?
So